Hey there, my name is Gary Sims and this is Gary Explains. Now, of course, Windows is no longer just on x86, on chips from Intel and AMD. You can also get it for ARM, for example, on the Surface Pro X, which has the Microsoft SQ1 processor in it, which is based on the Qualcomm Snapdragon processor. And of course, developers need tools to write software for Windows on ARM. And of course, Microsoft have Visual Studio, which has a compiler that can produce ARM code. But just recently, we had the release of LLVM version 12, including the new Clang compiler, Clang compiler, and that is now natively available for Windows on ARM. So when you go to the downloads section, not only do you see Windows 32-bit, Windows 64, but you also see a Windows on ARM version. So in this video, I want to just quickly show you how you install it and then run some tests to see how fast is the code that it produces. Okay, if you want to find out more, please let me explain. Okay, so downloading and installing is fairly simple. You go over to the LLVM website, you find the downloads. When you scroll down, you'll see the normal Windows 32-bit and 64-bit versions, but you'll also now see the Windows on ARM version. Download that file and then double click to install it. Follow the normal steps, next, until you install it just like you would just about any other piece of software. Now this gives you the command line version of the Clang compiler. There's also a version which is a drop-in replacement for Microsoft's Visual Studio C compiler. At the moment, it's best to use it from the command line. Of course, you can use it from nmake and so on and so on. Integration into Visual Studio is probably possible, but I actually wasn't able to do that at the moment. However, it does work very well from the command line. Now, you need to be running the normal command line environment terminal with all the right paths and things set up. That's part of Visual Studio, and then you can just use the compiler from there. So what I've got is I've got a compiler tester program, which actually came out from me building Speedtest GPC, because one of the tests in there is actually a sublec emulator. Sublec is a one instruction CPU architecture. I've got a video about that here on this channel, and I found as I was trying to build the benchmark that different compilers were giving radically different results, not just slightly different, hugely different results. So I ended up writing this quick program that runs the sublec emulator in 3 different ways to see what kind of performance it gives under different compilers, and therefore it's also a good way for us to see the performance of the code that these compilers produce. So I've downloaded that, it's on my GitHub repository there, and then I'm trying it with GCC under Windows Subsystem for Linux, I'm trying it with Microsoft Visual C, and I'm trying it with Clang from LLVM version 12. So let's have a look at the results that I got. So let's look at the top line here. This is GCC version 7.4 running under WSL, which was Ubuntu 18.04. Of course, there are many different versions of GCC that I could have tried. This is the default one you get for the Ubuntu 18.04, and when you run my program, it runs the sublec emulator in 3 different ways, and as you can see here, the total time for that test was 58.5 seconds. Now, if we move over to Microsoft's actual native compiler, that's the Visual C compiler, again, the same code compiled and run. I run all these tests, of course, several times just to make sure there was nothing funny going on. And we can see here it's actually faster in all 3 sections, but mainly in that middle section, we can see quite a gain there. I do recommend you look at the code on the GitHub repository to see the difference between these sections. And so we have an overall time now 49.5 seconds. And then finally, I took Clang, had compiled that. Again, exactly the same code. Full optimization on all these options that I'm using here, all 3 compilers, so nothing funny going on here. And we can see here it's actually slower, 64.5 seconds. So you can see one difference is that it's actually the same speed for all 3 sections roughly. So while the others kind of shrink and grow, kind of at least there is a consistency with Clang from LLVM version 12. Okay, so it doesn't produce the fastest code, however it was consistent in the 3 different methods that I gave it there in the C code to try to emulate the sublec computer there, the sublec CPU. So maybe not the fastest code, but of course it does give you compatibility, cross-compatibility across LLVM on all the different platforms it's available, including on Linux, on Windows and Mac OS. So, and also a good way to verify and check your code for errors and for cross-platform compatibility. Okay, that's it. My name's Gary Sims. This is Gary Explains. I really hope you enjoyed this video. If you did, please do give it a thumbs up and don't rely on the YouTube recommendation algorithm. Best to subscribe and hit that bell notification icon. Okay, that's it. I'll see you in the next one.